Good afternoon. Today we are still going to deal with Mohr circle. You have a brief introduction to Mohr circle, and I was carry on where we last stopped. Okay, so now if we have a transformation over here, just to quickly recall, this is our X and this is our Y. We have rotation about Z. And if we have an element over here, okay, so this is our element. And in our element, I like to do like what we did yesterday. We have a value of normal stress X. And then we have a value of normal stress Y. And you know that when they're pointing away, they are both tensile, right? They're pointing away. We understand that they are both what? Tensile. So once you have this, and I wrote down a condition, this is the case where stress X is greater than stress Y. Okay. As before, always label this as surface X, over here as surface Y. Okay. So now we start to draw or sketch Mohr circle. Over here, I highlight that this is our normal stress. And then over here, this is our shearing stress. And on the shearing stress, I want you to have a habit of doing this rotation clockwise. Bottom on the shear is rotation anti-clockwise. And later when we do shear, you will tend to understand why. Okay, now not yet, just do it. Okay. So we have written out that stress X is greater than stress Y, and both are positive. So over here, this is our stress X line. I'll extend it a bit further. And then over here, going to draw a vertical line. This is known as our stress Y. Okay. So we know for the fact over here, the shear stress is equal to 0. We immediately can write down this is over here is our point X. Over here where intersect 0 shearing stress is our point Y. So from here, immediately we can construct our Mohr circle. Okay. And then this is new now. Okay. You have to add on now. So at the center of the circle, this is known as our point naught, O. Okay. And I'm going to label this out. What you have over here now, the distance from the 0 stress up to here, this is known as your average stress. Okay. So the first formula that you learn, which is known as the center of the circle, also known as your stress average, will be equal to stress X plus by stress Y divided by what? Divided by 2. Okay. Now, if relative to the center of the circle, from point X to point Y is a rotation, it can be clockwise or it can be anti-clockwise by an angle of what? An angle of 2 pi. Or 180 degrees. Either clockwise or anti-clockwise does not matter over here. Sorry, it doesn't matter. So point X to point Y is rotation about what? Anti-clockwise by 180 degrees. Point X to point Y. I repeat, if you look at point X, from point X to point Y, right, is 180 degrees, not 2 pi, sorry, I do apologize. It's pi, okay? It's 180 degrees or pi rotation about point O, okay? About point O, and it's going to go in a counter clockwise direction. Okay. Now, this is on Mohr circle. Mohr circle is like your calculator. How to put the calculator into the real world, right? So if you look over here, okay, I want you to finish copying first before I start speaking the next time, okay? So now, focus on the element. I repeat again, focus on the what? Element, okay? Now the element from point X is also rotating in what? From point X. Okay, I think I'm having some serious issue with my eyes. From point X, point Y. Okay, so from point X, you can also call this surface point Y. It means the same thing, okay? So this is your point Y, and this also can be your point X, okay? So from point X to point Y, you realize that the angle of rotation is also how many degrees? 90 degrees. So what is more important is this concept, okay? In Mohr circle, the rotation between point X and Y is what? 180 degrees. In the element, the rotation between surface X and Y is 90 degrees. Okay, i.e., on Mohr circle is 2 theta on the, let me write the other way, okay? So on the element, it is theta. On Mohr circle is what? 2 theta. Are we clear? Because of point X and point Y relative on Mohr circle and on the element. Now, the next question we come about is it possible for the average stress to be equal to 0 when there are stresses acting at, or when stress X and stress Y are not equal to 0? Is it possible? And the answer is yes, okay? So now I'm going to do normal stress again, X, Y, and this is our rotation about Z. Now we have an element, and it's only in this condition, unfortunately, okay? So what you see over here, you see that this is your stress X, and this is your stress Y. Okay, so there's only one condition where stress X is equal to minus what? Stress Y. So when this is the case, stress average can be equal to 0. Okay, so let me draw this out for you. So now we have our Mohr circle. Again, we label this as X, and then we label this as Y, okay? So we state that what? Stress X is equal to minus stress Y for this condition and this condition only. So over here, you can see, I think the screen has high enough resolution. You can see 2, 4, 5. I draw 5 boxes towards the right. And then I am going to draw 5 boxes towards the left. 2, 4, 5. Okay. So when this is the case, we label this as your stress X line. This is your stress Y line. So over here, we happen to call this our point X. And over here, we happen to call this our point Y. So from here, we can construct another circle. So now when we construct this circle, it looks like this. So over here, the center of the circle is our point O. And what we realize over here, it makes the condition, it satisfies the condition that the average stress is equal to 0. Okay. So the average stress means it means nothing. It's just the center of the circle. Do not quote an average stress magnitude when you're designing a structure. It don't mean anything at all. Yes or no? You can say, Eugene, this is 0 stress. We can use anything. That's not true at all, is it? Okay. Now again, have the habit of drawing the shear at the top is clockwise, at the bottom is counterclockwise. Now I want you to focus on another point. Okay, so point X and point Y for this case are also known as principal stress. Okay, are also known as what? Your principal stresses. Okay, so the principal stresses, I'm going to label this as stress 1. And over here at the same point is going to be stress 2. Okay, so your principal stresses are your stress 1 and your what? Stress 2. So if we look at the principal stresses, what is unique is at the principal stresses, which is your stress 1 and 2, the shear stress is equal to what? It's equal to 0. Okay, the shear stress is equal to what? 0. I beg your pardon. I'm trying to do something over here. I could do it yesterday, but today I can't. Sorry. How to do that? That I can. Yesterday you saw I switched screen, right? Come on. Oh, on, my bad, my bad. Bear with me. Screen assignment. Ah, jawohl. Screen assignment. Come on, you cheeky sort. Go on. I'm trying to do something at my end. No. This is bad deal. No, wait. Bear with me. Right. So I want to do something now. Okay. To let you visualize. Okay. I need a white blank paper. Anyone have blank paper? Yeah, I'm okay. Muchas gracias. Right. Okay. Sit in focus. Autofocus. Can you see my hand? But it's not in focus. Wait, my bad. Come on. Can you all see? Right. Okay. I know you are pissed off with chalk. I understand that, okay? Put an element here. And then we are just going to have a stress x direction. Okay. Okay. We're going to have a stress x direction. Now, focus. When we have a data from a materials handbook, like this, okay, bear with me. If we have a materials handbook, if you look in not the last page, the last year, I'm going to copy